Everyone, good morning, good afternoon, and good evening, dear authors and invited guests. Welcome to a technical session 3A. My name is Recha, and I'm the moderator of this session. On the behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, as we are well aware, we have been facing a new normal situation while overcoming the pandemic. Hence, the conference has been shifted to the hybrid mode. We are very thankful to everyone who present on this platform to go along with us digitally for the conference in these unpredictable post-COVID circumstances and making this conference more productive. Also, we wish everyone and their families to a protected time. We hope you will enjoy the 2 days of knowledgeful and interactive sessions. Also, there is a special note for all the presenters. You will be given 10 to 12 minutes for presentation and 3 minutes for question answer. After 10 minutes, I will raise a gentle reminder to conclude the presentation. And I request while the presentation is going on, other participant kindly be muted. There's another request to all the participants that you all stay connected with us till the closing remark. If you have any query and any updates, then you can write to me in chat box. Just before we get started, I would like to introduce our chair, Dr. Dalia. She's an associate professor at CIC Canadian International College. She was head of information system department in the French University in Egypt, co-director of the CRI Research Lab, associate professor of management information system. Welcome to you, ma'am.
Thank you. Thank you, and many thanks to the ICICT conference and greetings for its 7th edition. I hope each year it will be another edition, successful editions.
So thank you so much, ma'am. And now we are start with the papers. So we'd like to invite our first presenter.
Okay. Our first presenter is Mr. Mahdi Hassan Abid, machine learning approach to predict SEER cancer.
Actually, my teacher is sick right now, so that's why.
Dear presenter, you may please start your presentation.
Actually, DM Abid actually sick. My teacher is sick, so can I give the presentation?
Yes, please. You can start your presentation.
First of all, thank you for give the opportunity. Our presentation topic is a machine learning approach to predict CR cancer. That is for actually biomedical sector. And if we see, it is presenting by Tariqul Islam, that is me. And our actually the main focus in this paper for CR cancer. Actually, the CR cancer means surveillance, epidemiology, and end results. We hear some of the cancer institution like as National Cancer Institution of USA we using data set from NCI. In this actually paper, we found this in our data sets. There's a many times of malignancy pointed inside us. So that's why we can see the negative and growth of. Like as we will focus is whether individually danger of malignant growth or not. It is in the outflow of data set that is mentioned by 1 or 0. And the preservance and desire for benefit manages gold patients options to outsagger provisions and limits. In this, we also hear some AI for predict the cancer and the 3 algorithm in machine learning. Next slide, we see some of the keywords we're using here, CR cancer and machine learning. And if we introduction about about this paper, actually CR means authoritative source for cancer surveillance epidemiology and in results. Actually, this program actually informative about many cancer statistics that is for or reduce people compulsions. Actually, the main point of the paper is depending on the select if the manufacturers we will find whether individual at threat of malignant growth or not. And then we see our proposed method. In the proposed method, we actually use our NCR data sets, that is research areas supported by SRP. And we can see there these data set almost 14,000 separated patients interviews by 98% of all utilized hospitals. In here, we see our purpose engaged development. That is first our generation and collected level data, and then we just data pre-processing and clearing, and we split the data set for training and testing purpose, and then training data sets we can also use for machine learning and finalizing that. Also, we can attach here the machine learning model validation. And finally, we can develop a optimization ML model for that. And if we see our accuracy rule for our 3 algorithm, that is ANN and SVM and DT. Yeah, our accuracy is and sensitivity is depend into that regulations and rules. Yeah. And then we see our data preparation. We can give the details. What can we describe that? In there is a we have 3570 data sets. Actually, that is column with medium and standards deviators, and there is a 3 highlighters for each pictures. Actually, that is separated by, and 3 different field radiations like as radius AC in 13 and Or's radiation fields. And if we see our confusion matrix for 3 algorithm, and in below we just describe that table. That is, we see our total column information of data sets. We describe the full of confusion matrix, and finally we can say that our decision tree is the best accuracy in around 3 algorithm. In here we can actually 70% are for preparation data testing and testing purpose. It is 30%, and in the future we can apply some AI methods for that. It is now it is using will continue with machine learning. Finally, thank you very much.
Thank you. Thank you for your effort. The presentation was clear. Thank you.
Ma'am, do you have any question regarding this presentation?
No, actually, I don't have. If any of the other speakers have any questions, that's fine for me.
Okay, so move ahead our next presentations.
Okay, next presentation, Sandeep Gojineni, paper titled Analysis of Vulnerability Trends and Attacks in OT Systems.
Hi everyone.
Hello.
Just a second, let me share my screen. So, are you able to see my screen?
Yes, it's clear.
Yeah. So, hello everyone. Myself Sandeep Gogineni Babu. Today I'm going to present my work on analysis of vulnerability trends and attacks in operational technology systems. So let me give a brief overview of the topics that I will be presenting today. I will give a brief introduction to OT systems and some of the security issues that currently affecting the OT systems. And rest of them are the subsystems like smart grid power systems, SCADA systems, embedded, and PLCs. And I will provide some conclusion and future work of my research. So coming to operational technology systems, systems that process operational data, including electronic telecommunication or computer systems and other technical components, falls under the category of OT systems. Basically, these systems are used to control and monitor various devices and industrial processes and make adjustments whenever it is required. In other words, the OT systems uses the combination of hardware and software to perform real-time operations and to detect if there are any changes occurred during the process. And some of the example of operational technology systems include manufacturing execution systems or supervisory control and data acquisition systems or energy management systems. In general, OT systems ensures the safety of industrial operations by continuously monitoring them, and OT networks works at the industrial level to process the operational data of any organization. Some of the standard networking protocols used by OT systems are DNP3, Modbus, Profibus, etc. And some of the security issues with them are earlier OT systems security were mainly concerned with the process of their control systems and ignoring the risks that were coming from the network connectivity or other outside issues. This is because OT systems, which were physically separated from informational technology systems, limited the threat environment when compared to today's internet-based threat environment. Also, earlier there were dedicated lines to the operational technology systems, but now the connectivity is over the internet, which makes every device accessible over the network and causes another point of attack. So this figure outlines the cyber attacks on each year, which indicates as the technology is growing, the number of attacks are growing, and the vulnerabilities with respect to OT systems have been discovered and exploited by the adversaries. Also, the attacks like Stuxnet and distributed DOS attacks targeting OT systems determine the need to protect the systems in order to maintain the viability of today's economy. Smart grid power systems in general have enhanced the reliability and efficiency in recent times by supplying electricity through broadband and distribution. And also this approach has been cost effective and it has a high impact in terms of economy and security. Basically, the smart grid power system consists of two kinds of security impacts. One is physical security, which aims to mitigate the effects of natural disasters or other physical attacks, even catastrophic blackouts as well. The other one is the cyber security, which aims to address the flaws introduced by the integrating of physical systems and cyber systems. So cyber attacks were previously thought to be incapable of posing a threat to the security but they have caused numerous security issues in recent times and have become a major concern for both the users and the clients of industrial control systems. So in 2016, according to the Common Vulnerability Exposure Database, there were 4 incidents recorded, and there are many more incidents, but for internal security reasons, they are not provided much on the CVE database. Some of the attacks like load altering attack, random attack, load redistribution attack, and economic attack are various kind of attacks that are possible on smart grid power systems. And there are a few mitigation strategies like public infrastructure standards, certificate attributes, trusted computing, and other tools are also available. SCADA systems, supervisory control and data acquisition systems are used in industries such as energy, oil and gas, water, and many more. Basically, it consists of centralized unit which controls and monitors the entire site, and it works by operating signals to communicate through channels, which provides the user the remote capability of any equipment in a given system. And it also uses distributed database and consists of 5 essential components like PLCs, RTUs, human-machine interfaces, communication infrastructure, and supervisory system. So there exist several vulnerabilities in each of these parts, and the attacker can get the system by exploiting those vulnerabilities. So as we see in this diagram or graph, from 2007 till 2020, there are around 948 incidents that are reported on CVE database, and the peak of the incidents were reported during the 2011 to 2016. And from these incidents, there are many vulnerabilities like buffer overflow, cross-site scripting, improper access control and authentication, privilege escalation, and SQL injection are found. And detailed description are given in the paper. So RTUs are integral part of SCADA systems, which monitors the field data and sends to SCADA control servers for analysis purpose. So there are specific incidents with respect to RTUs which were reported on CVU database as shown here. So total number of 43 incidents were reported till 2020. And if we consider from 2019 and 2020, most of the SCADA incidents that were reported on SCADA graph are related to RTS. This indicates us that the interdependency between the SCADA components will be one of the important aspects that should be considered, and in future it is necessary to develop countermeasures for SCADA internal components like RTUs and PLCs as well. So here are the list of possible attacks on SCADA systems. For example, the Radius, which is a remote authentication dialing user service DOS attack. It causes damage by limiting or denying access to its resources or by denying the service to authorized users. And traffic sniffing is a kind of attack where attackers use to capture the packets traversing within the network through a network analyzer, or the integrity attack is accomplished by delivering inputs to other devices in SCADA systems, causing data corruption. So detailed description again is given in the paper. If anyone interested can look how exactly these attacks works. So there are some countermeasures or solutions that are available, like filtering and monitoring mechanisms or policy approach, or by using mathematical and computational models to detect intrusions are available. But the disadvantage is they are limited to specific architecture or specific test bed. So embedded systems, these systems are advanced in recent times, which has led to increase in many devices in terms of critical communication infrastructures. And basically embedded systems are computing systems designed for dedicated functions to interact with general purpose systems. They also include hardware, software, and other mechanical parts. And recent times, most of the embedded systems are used in Internet of Things, which has resulted security breaches. So one of the main problem with embedded device is the firmware, which is a software program that provides a control for embedded systems. So these are related to permanent storage devices such as microcontrollers consisting of internal storage mechanisms. And microprocessors are also considered as the core of electronic systems, and software through firmware can effectively use various hardware interfaces associated with them. And the firmware has become the primary component of any automated method, and vulnerabilities like programming errors or web-based vulnerabilities or weak access control authentication causes most of this. So hence, because of this, the securing this has become an important aspect in real-world applications or devices. So according to the vulnerabilities reported in CV database, again, this list is from 2000 to 2020, and around 843 incidents were reported on embedded and firmware systems. And as we see here, the rise of incidents is starting from 2011 till 2020 till now, and it shows how important the vulnerabilities are, like memory control hijacking or reverse engineering attacks, and the memory vulnerabilities like SQL injection or cross-site scripting shows on these kind of attacks. And if adequate mechanisms are not implemented, attackers will have an easy time breaking into the system and causing damage. PLCs are real-time systems that closely monitor and control plant devices to keep the process functioning correctly. Basically, these receives information from input device and processes the data and figures the output based on the pre-programmed parameters. So, and this program in PLC considered as logic and executes within the control flows. There are several techniques used by the attacker to tamper the input-output operations on the PLC, and also there are mechanisms or certain attacker-based solutions where countermeasures or implemented security strategies can be evaded using PLCs. From 2011, around 132 incidents have been reported as shown here, and the highest number of incidents are recorded on 2012 and 2014, and again from 2019 to 2020, indicating how susceptible the PLCs are at present. So to conclude, in this paper, I have presented a list of attacks on different subsystems of operational technology systems, including their vulnerabilities. I also performed analysis on cyber incidents which are reported in a common vulnerability exposure database to determine the trends. And this work starts as a starting point to develop standard set of mitigation strategies by bridging the gap between different OT subsystems, and helps to develop solutions to make cyber attacks on OT systems resilient. And based on this survey, we will next create a dashboard for each OT subsystem and then integrate with the software-defined network technology using NIST principles and analyze them in terms of performance, safety, security, and reliability properties. Thank you.
Thank you. Thank you for your efforts.
Now we can call our next presenter.
Okay, next presenter is Yang Lu, paper titled Simulation Model of Repository Sounds and Technology for Separating Characteristics of Pulmonary Disease.
Well, yeah, I'm Lo Yang. Good morning and good afternoon, ladies and gentlemen. Yeah.
Hello.
Wait a minute. I will show you my presentation. Okay. Yeah. This is my presentation. Yeah. I'm a PhD student from Kazin, Kharkiv National University of Ukraine. I'm very happy to be able to participate in the conference. The topic of my presentation is a simulation model of respiratory sound and the technology for separating characteristics of pulmonary disease. This is our co-author, Lieutenant Babakov and Nguyen. The outline of my presentation show here. First, I'll do some introductions for the respiratory embracing, and then will be the theoretical basis and the equipment basis for our research, and then will be the structure framework of respiratory diagnostic system virtual family doctor, and the next part will be conclusions and references, acknowledgement, and in the last will be the information and the contact of the authors. Yeah. First, need to show you the subject of our research. The subject of our research is the acoustic noises, or you can call it as the respiratory sounds. In the process of human breathing, respiratory sounds are produced, and the sounds contain a lot of information. A lot of information related to the structure of the human airway. In our research, we use the computer and the signal processing technology to collect and analyze the breath sounds to study the frequency spectral difference between normal and abnormal respiratory sounds. And based on these results, a virtual family doctor is further established as a respiratory disease diagnosis system. Here show you the respiratory process of a human. In general, the respiratory process can be divided into two stages, and inhalation and exhalation. Inhalation, no oxygen intake, and exhalation, the carbon dioxide exhale. Yeah. And we think we use a semi-Markov model of respiratory cycle to describe the healthing process. Each stage can correspond to the one phase. Yeah. If you holding the breath, then in sometimes it can be divided into three stages. It means three phases. And the next part will be the technology which we use to describe or analyze the respiratory sound. It's telephone, Samsung, yeah, and this is our stethoscope, and this is the point where we collect the information of the lung noises. And this is the program interface which we developed for our research. Yeah. And there is some method or result in our study. The first technology we use is the statistical characteristics of the respiratory sound. And in the left and the right, in the left is the distribution density for different phases of respiration for healthy and for healthy one, yeah. And diseased lungs, yeah, were experimentally studied here. And in the right is the for general the respiration process. The one is the left lung, and the second two is the right lung. And the next way we used for our research is using averaged spectral. We do FFT, no fast Fourier transformation for the respiration sound recording, and get the averaged spectral. And for the people, normal people and the unnormal people, there have very obvious difference in the results of the spectra. and also this is also our results for, and the figure 7b shows the differential spectrum. Yeah, and this is also our research research for by using averaged spectra for the different stages of the pneumonia. And 1, 2 means here is the initial stage of pneumonia. 3, 4 means 5 days after the onset of pneumonia. And figure 5, 6 means 4 days after the start of taking antibiotics. And the next method we use to separate the information from the respiratory sounds is the moment characteristics. And this is the moment characteristics of the average spectrum. There have some wait a minute. For a person with a lung disease, his breathing is more rapid, and the average frequency of breath sound is higher. The difference in average frequency is around 25 hertz. 25 hertz, yeah. And the next method is the spectrogram. Spectrogram, yeah. Image of the noise spectrograms under normal and abnormal conditions, yeah, can be used to identify the pathologies by using the approaches in the field of pattern recognition. The figure 10 here, yeah. Figures 10C and D is the realization, temporary realization of the noise of a healthy lung and pneumonia affected lung, yeah. A normal, B abnormal, yeah. And the CD means their spectrograms. As the next slide shows by using different samples, which means the different resolution of frequency. Yeah, A the resolution is 10 hertz, and B is 2 hertz, and C is no 0.6 no hertz. This is all the normal healthy examples, and the D is the unhealthy. It means the pneumonia. Yeah. And the next stage of our research is to decide or to create the criteria for our comparison to do the diagnostics. We can compare the example or the recording of the patient with the standard recording, or we can compare the left and the right lung noises of one person. Yeah, okay. Next will be based on this research and the results, we can create a respiratory diagnostic system. It will work it as a virtual family doctor. This is the structure framework. This is a structure framework. Why do we need such a virtual family doctor? First, we live in an era of convenient internet. It's very convenient for us to use to chat or communicate or update, upload or download the information. Second, today's computers have ample capability for storing and computing data. Third, save medical resources and make doctors and the patients more comfortable. build digital twins, predict future disorders, and provide preventive treatment. The file is secret. It will be more safe for the doctor to do the diagnostic. Conclusions show here. In this part, I want to say that for second, wait a minute, yeah. Okay, the 4 points there. This approach can be extended to create a completely digital medical records, even digital twins for all patients for future disease prediction and preventive treatment matter. It's very interesting, I think. And the future work not only to play a role as a virtual doctor. It can be a trainer for train the students of medicine students. It's because we can use these characteristics to create the digital recording of the respiratory sound for a patient, and the student can hear the sound. The doctor, the student, medical student can hear the sound, and it will be a very benefit and interesting training for them. And this is the references of our which paper we read and use in our research. And thank you for your attention. I wish everyone good health and good work with path of science, full of flowers and spreads. Yeah, this is the information and the contact of the authors. Yeah, that's all. Thank you.
Okay, thank you.
Any questions?
No, thank you.
Oh, thank you.
Yeah, to go ahead, I would like to invite our next presenter.
Okay, it's Gulay Kambologlu, paper title and adaptive self-modeling network model for multi-level organizational learning.
Hello.
Hello.
I'm sharing my screen.
Did I pronounce your name
yes.
in a good way?
Yes, I'm Gülay Candalıoğlu.
Okay.
Can you see my screen?
Yes.
Okay. I'm Gülay Candalıoğlu, and I will present an adaptive self-modeling network for multi-level organizational learning paper by me, Jan Schröer, and Peter Lofsma. Today, I'll talk about mental models first as relational structures in your mind, and then I'll explain multi-level organizational learning and its levels, like individual learning of mental models, formation of shared team mental models, creation of organization mental model, feedback learning of teams from organizations, and feedback learning of individuals from teams, and improvements of individual mental models in the end. And then I will describe our example scenario, and I'll show the simulation results to you in the end. Mental models. Learning takes place in humans' mind in many different ways, such as trial and failure, observation, communicating with each other, and sometimes even thinking. In our minds, we have representative models of situations to understand and interpret them. We comprehend the things and create linkages between them by the help of these inner models. In other words, we have mental models of the outside world as relational structures. We use them, we adapt them, and we control them. Using mental models is a lifelong process that starts very early and continues until we die. For example, when we look at the development of humans from birth, we can see that the first mental models are created for solid matters and their relationships with us in their mind. And then as they grow up, they start to have mental models of abstract concepts more. Our mental models adapt through learning and forgetting by time and experience. Our understanding of a concept that we know but don't use it yet changes when we directly use it. Even our understanding of the world sometimes changes when we experience some difficulties or extreme happiness, for instance. These changes are controlled by some factors that I will be explaining in a second. We also have the ability of controlling our mental models. Factors like learning speed and persistence determine the amount of control over the adaptation of our mental model. For this overall cognitive architecture, we have representative layers for the self-modeling network models. We have a base level for use of a mental model, first order self-model level for the adaptation of a mental model, and second order self-model level for the control of adaptation mental level. Multi-level organizational learning has a feed-forward and feedback mechanism, as you can see in this picture. Crossan et al. Said that in their research, through feed-forward processes, new ideas and actions flow from the individual to the group to the organization levels. At the same time, what has already been learned feeds back from the organization to group and individual levels, affecting how people act and think. And also, Vivier et al. Said that there is growing consensus in the literature that the theory of organizational learning should consider individual, team, and organizational levels. This multi-level structure of organizational learning can be seen in this figure. As I said, there is feed-forward and feedback learning between the levels of organizational learning. We have these levels and we have these phases to represent levels of organizational learning in our example scenario. I'll directly explain these phases. In our example scenario, in the first phase, individual mental model usage and learning is placed. This is the individual's mental model improvements place. And then in the second phase, shared team mental model formation happens. This is a type of feed-forward learning because it's from individuals to teams. And then the third phase is again a feed-forward learning. It's from teams to organization. Shared organization mental model formation is here. And in phase 4 and 5 are the feedback learning parts of the multi-level organizational learning. In phase 4, teams are learned from organization by feedback learning. And in phase 5, individuals learn from the teams. And in the end, in the final phase, individual mental models improve again by the feedback learning. The phase 1 and phase 6 are different because there is no shared mental models in the beginning. But in the end, there are shared mental models for team and organization, and individuals can learn from their teams or organization. This is the base level of our model. This is like skeleton of the model. We have base level states, individual mental model states for persons, for person A, B, C, and D. And then we have base level states for teams and organization. There are no connections between team level states or organization states, base level states, because there is no shared mental model in the beginning. And for the persons, We have connections for some states, but we don't have some for some. It means that, for example, for person C, C has knowledge on task B, and task C, but not for the task D. And for example, for person D has no knowledge for task A in the beginning. This is first order self-model level. We have adaptation tools for the network here. These are the double states controlling the weight of connections between base level states. For these connections, we have these double states for person A, double states for person B, C, and D. And also we have for teams and organizations. Double states have interconnections between them. The meaning of this is teams are formed by individuals, and individuals can learn from their teams. This is the feedback and feed-forward learning arrows, actually. These double states control the connection weights, and they are responsible for activating the base level states. For example, in the beginning, we don't have shared mental models, but by time we will have with the help of these double states. And this is our overall model with the second order self-model level, the third layer. Here we have tools for control of adaptation, like higher order double states. These higher order double states controls the weight of inter-double states connections for feedback and feed-forward learning. And also we have H states. They are for the control of speed of adaptation. Context states are responsible for starting the phases. As I just said, there are 6 phases in our model, and context states starts the phases, control the phases. This is our simulation results. I will show it in a bigger way in the next slide. Sorry, because of size. This is our overall simulation results. Between 0 and 200 in the first part, we can see the mental models of 4 different individuals having different levels of knowledge for different tasks. Because person A and C has no connection for task D, as I just explained in the previous slides, the base level state of this task, the task D, remains 0 in the beginning. Same also valid for task A of person B and D. And then in the next phase, shared team mental model is started to be created by individuals. A type of feed-forward learning occurs here, and then this shared mental model is maintained by the 2 teams. Also, because people don't have perfect persistence value, they forget a part of what they learned, and you can see decreasing lines here. This is because forgetting things. Then here, the teams shared mental models unificate, aggregate, and create the organization shared mental model by feed-forward learning again. Then team mental models strengthen their connections by feedback learning from the organization shared mental model. This is the fourth phase of the multi-level organizational learning, the feedback learning from organization to teams. And the higher order adaptive connections from organization to team double states become activated here in the first or the self-model level, the connections from organization W states to team states activated. And then individuals started to learn from their teams, shared mental models by feedback learning again. Higher order adaptive weight states for connections from teams W states to individual W states are activated in this phase. The learning happening in this phase provides persons to improve their unknown connections in the next phase. For example, person A starts to learn about task D right now. A didn't have any knowledge on this task in the beginning, but now he or she started to learn about this task with the help of the team's shared mental model. And in the last phase, in the final phase, individuals use their mental models and improve their knowledge by habit learning with the help of feedback learning, with the help of their teams. Thank you for listening. I can shortly summarize what I talked about. I first explained mental models, and then organizational learning with multi-level structure, with its multi-level structure. And then I described our example scenario, and I showed our simulation results. If you have any question, you can ask.
Thank you. Actually, I don't have any questions. It was very clear. Anyone have any questions? Okay, let's move to the next paper. It's Vasilvis. Titled Accuracy of Potentiometric Mapping in Solutions.
Ma'am, I think this paper presenter is absent.
Is absent? Okay, let's move for the last one.
Last presentation. Yes, ma'am.
Okay, it's Reem Aman. A new innovation concept of end users' contextual and behavior perspectives.
Thank you. I'll share my screen. Thank you, everybody. My name is Reem Aman, and I'm presenting to you my PhD study. I am supervised by Professor Shah and Dr. Janet, and my study will explore a new innovation concept on end users' contextual and behavioral perspectives. So my presentation today will be divided into an introduction, a study background, a methodology, a theoretical framework, and the proposed conceptualization, and a conclusion at the end. I'll begin by giving you a brief overview of the study. So I'm looking into innovation by the household sector. It's a phenomenon on a large scale, and it includes intangible and tangible innovations. Unfortunately, all these type of innovations lack some sort of a conceptual clarity. So we aim to develop an overarching conceptualizations, and it will include all types of innovations such as ideation, objects, and practices. And the approach we will take is by exploring, sorry. Yeah, so my approach will be by exploring household innovation scope, and I will do that through visual analytics of big data. The background behind this study is that first, intangible innovation is very hard to distinguish, can be very difficult, especially it's the diffusion. So we're focusing on intangible innovation from a process perspective to identify it and capture it. Unfortunately, traditional method cannot be reliable. For example, in a survey, we ask people, household sector, about innovation that they've done. They might associate it with daily practices because they don't know the nature of, they don't understand the nature of the innovation that they produce. So how are we going to do that? So to do this, we rebuilt a design approach. It will be integrating computational techniques, integrate techniques provided by information systems. So the design approach will have 3 phases, and these 3 phases are informed by the design science research paradigm. And we took this approach because this paradigm is suggesting creating innovation, developing artifacts that capture the situation or the reality of domain we're studying. This is an illustration of the 3 phases in this table. And so what's the theory behind this phenomena? Basically, the theory says that the household sector innovate and their innovations diffuse in two paths. The first one is from the consumer to the business, and the second one is from the consumer to another consumer. And in the second one, where it goes from a consumer to consumer, that can be in a community context, and which can extend to a collaborative nature and a distributed nature. And in the first one is more of an individual mode of innovation. So how are we looking at intangible innovation? So we're looking at intangible innovation, as I said, from a process perspective. So we're going to conceptualize it as an extension of scope, and the definition of scope that we're adopting is the extent of the area or subject matter that something deals with or to which it is relevant to. And in this figure, I have illustrated the innovation types, which is the idea, the object, the practice, and we have the patterns of diffusion that we'll be covering in the study. And so in conclusion, we're going to do a new methodological foundation based on a design science research, and that will be informed by the household sector. We're going to do that to propose an artifact, a conceptual artifact, and at the end, this will promote the phenomena by giving more of a conceptual clarity of household sector innovation in the form of invention and reinvention. Thank you. If you have any questions, please ask.
Thank you.
Ma'am, any questions regarding this presentation?
No, thank you, Richa.
Now we had completed all the presentations, and I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and all the presenter would be getting digital certificate in 2 working days. And further, all the papers are already forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of ICICT. And I also thank our session chair for chairing this session. Thank you so much, ma'am, for your valuable presence.
Thank you,
And
Richa.
I would like to ask my team to display the certificate. Ma'am, this is a token of appreciation on behalf of ICICT and a Global Knowledge Research Foundation.
Yeah, we need the certification.
Today, all presenter would be getting digital certificate within 2 working days by email. You will all get certificate. And there is one more request. Kindly please turn on their cameras for a quick snapshot for virtual conference. Thank you so much, everyone.
Thank you.
Thank you.
Thank you.
Thank you.